Okay, so let's start with our discussion from yesterday, where we were learning about the timers. We learned about different timers, the hello timer, the dead timer, and the forward delay timer, right? And with the forward delay timer, we also learned what are the different port roles and port states that a particular spanning tree interface goes through, right? Before it starts to forward the data, right? And we also learned about few features like port fast feature, and we also learned about root guard and BPO root guard, right? So all those things we'll look at in the practical today. Okay. So let me just simply connect first two switches together, switch one and switch two. So switch one is connected to switch two. Now, the moment I connect these two switches together, now you will see that the spanning tree starts to run on them. Okay. We can clearly see on switch number one, it's currently on a it was on a listening state, then it moved to the learning state, switch one. Switch one's fast ethernet 0/0 is in the learning state, right? And then once the 15-second has elapsed in the learning state, it goes to the forwarding state. Okay, it goes into the forwarding state. Now the same thing we can see on switch number two as well. Okay, but obviously 30 seconds has elapsed, so we may not be able to see the transition from disabled to listening to learning, etc. But we'll see a state over here. Okay, so you can see on switch number two, fast ethernet 0/1 is the role is root and it's in the forwarding state, right? Whereas for switch number one, the fast ethernet 0/1 is in the designated port and it's the forwarding state. Now, my question is, with just these two outputs in hand, can you tell me which is the root switch?
The right side.
The right side is the root switch.
No, wait. The designator is there, right? This side is the root. Role is also written root in the right side, but here left side the role is designated.
Yeah.
No, right side the role is given, right? It's root.
Yeah, role is given as root. So can you tell me which is the root switch? Which one of them is the root switch?
I think the right one only should be the root switch.
Okay.
And here also it will
Why?
written. uh, if you do the STP details, right? I think scrolling up there was a row. It will this is the root like that. It will be written. So
No,
there's
no,
also
forget that.
okay.
Just by looking into this particular output from the there,
So from this
which will
output
be the
actually, from
hmm,
this output actually both are in forwarding state. And
okay.
one the role is root and one is designated. So root right side only is the thing.
Right side is the root switch. That's
Root
what you mean,
switch.
not
E-
root switch. Okay.
Root switch, yes, root switch.
Okay. Now, why do you say it's the root switch?
Because in the role itself is written as root.
Okay, this role is for the interface, not for the switch.
Oh, okay.
Okay, this is the
Interface role. The
interface role.
interface role.
Ah, now tell me, which will
Uh,
be the root switch? Okay.
both looks almost same only here. Nothing we can
Hmm.
identify from this. Cost is
Hmm.
19. Cost is 19. Both have a cost 19 to the root switch. So anything here we addresses into the MAC address also showing with that also we can identify.
Okay.
From this output, I think it is
So,
not clear that much. So this row we
okay.
can't see.
Yeah. Yeah. All right. So the confusion that you have is absolutely fine. But please remember this output that you see in front of you is the information about the interface. Okay, it is the information about the interface. It does not tell you anything about what is its cost to reach the root switch, or what is its cost like other than like basically what I'm trying to say is this is basically the information about the interface. These two outputs that we see on both the switches, this information tells about the interface spanning tree information. I mean, the fast Ethernet 0/1 over here on switch number one, what is the information? This fast Ethernet 0/1. Fast Ethernet 0/1 is in the designated port, is a designated port. Its state is forwarding, and its interface spanning tree interface cost is 19. Okay, because it is a fast Ethernet interface, the cost is 19. Okay. Similarly, here also it says this is fast Ethernet interface. Its role is root. It's a root port. Okay. On this particular switch, the role is root port. And because it's a root port, obviously it's in a forwarding state, and its spanning tree cost is 19. This cost does not mean its cost to reach the root switch. It's its own spanning tree cost. It is its own spanning tree cost. Here also it says about its own spanning tree cost.
So own cost will be zero only, right? Own means self reaching self.
No, no. If you remember when I said spanning tree costs are created by default for each and every interface, there is a spanning tree cost, right?
Okay,
Spanning
got it.
tree
That yeah, got it. That
interface cost.
19. It was they were adding the 19, and then making it 38. Like
Exactly, exactly. This one, this cost. It's talking about this cost.
okay,
Sorry, where is that?
yeah, 19 is there. It 19, 14, 6, 4, 2.
Yeah, these costs. It's talking about these costs. Okay, it is not talking about the cost to reach the root switch. It is talking about its own cost to it is talking about its own interface planetary cost.
Cost.
Okay, give me a minute. Give me a minute. So as I was saying, this cost is the interface spanning tree cost. It is not the cost about reaching the root switch. It's just telling you the information. What is its cost? So sometimes with the cost, people are able to identify what is the bandwidth. Is it a fast Ethernet link? Is it a 100 Mbps link, or is it is a 200 Mbps link, or is it 1 Gbp or 10 Gbp, etc.? They can easily find that out through that particular command or through that particular output, right? So enable show span tree. Now, if you remember when we were discussing the designated port on root switches, we I said that on root switches, all the interfaces are designated port. All the interfaces are designated port. You will find root ports only on non-root switches. So let's go back to our that diagram. Okay, so we had switch number one acting as the root switch, right? We had switch number one acting as a root switch, and we can clearly see that yellow color is the designated port, and you can see all the links or the interfaces are designated port. And on all the other switches, which are non-root switches, you will find one root port. You will always find one root port on every non-root switch. So over here in this diagram also, in this diagram with the output, we can clearly see that this switch number two, has a root port. That means this is not a root switch. If it has a root port, that means it is using this root port to reach the root switch. That was also one of the definitions of a root. A non-root switch will use the root port to send data towards the root switch, right? But a root switch will never have a root port. It will always have a designated. So automatically we can clearly see that this switch does not have a root port, and hence this should be a root switch. Clear?
Yes, it is got. Yeah, I remember that now. Yeah, clear.
Yeah. Now let's go to switch number three and just do the or execute the same command. Show spanning tree active. and we will see there are no spanning tree instances as of now. But the moment I connect this interface, switch 2 with switch 3, we will start seeing some output. Okay. So we will see it's in the listening state, right? The fast is in a 0/1 and switch 3 is in listening state. It will stay in the listening state for 15 seconds. And then you can see it moved to the learning state, right? And it will stay here again for learning state for 15 seconds. And once that is done, it will move into the forwarding state. It has moved into the forwarding state. Okay, so previously, this interface was in disable state. The moment you connect interfaces, they'll start running, or the moment you connect cable into those respective interfaces, they'll start running, what do you say, spanning tree on them. And those interfaces, based on the spanning tree cost, based on the root switch location, etc., they'll decide which is going to be a root port, designated port, blocking port, etc. So currently on switch number 4 also, we'll see some kind of, I hope we are able to see before it crosses. Okay, yeah, it has moved into the forwarding state. Okay, you can clearly see switch 4 is a non-root switch because it has a root. Okay, it has a root port. Okay, switch number 1, again, let's do a show spanning tree. It does not have any root port. All the ports are designated port routes. That is why it's a root switch. Okay, now let's go back to our output over here. So when we do a show spanning tree active, it shows spanning tree active for VLAN number 1. It shows spanning tree active for VLAN number 1. That means I can have multiple spanning tree protocols running for different VLANs. I can have multiple spanning tree protocols running for different VLANs. So let's say that I have, for example, 20 VLANs. Okay, I can have one spanning tree instance running for VLAN 1 to 4. Okay, or 1 to 5. Okay, then the second spanning tree instance for 6 to 10. Okay, then third spanning tree instance running for 11 to 15, and the last spanning tree instance running for 16 to 20 VLAN. So if I do show spanning tree instances, or when I do show spanning tree active, okay, here it will show me show spanning tree active. This show spanning tree active is for switch number 1. Okay, and on switch number 1, since there is only one VLAN number 1, and the spanning tree is running only for VLAN number 1, show VLAN, we will see only one VLAN that is configured on this switch, which is the default VLAN. We have not configured any other VLAN explicitly, right? So there is only one VLAN, and hence this spanning tree instance is also running for that VLAN alone.
So all the switches have only one VLAN, right?
Currently, when you enable them, it is running the spanning tree instance only for VLAN number 1. That is why you will see VLAN 01. But as I said, if you have like no, it will show spanning tree active. When we do a show spanning tree active, it will say for VLAN 1. Okay, for VLAN 1, it will show which are the interfaces which are in the designated port role or forwarding state. For VLAN number 2 also, it will show which are the interfaces which are in the designated port role or different port roles. Okay, that
But
particular
at
part is
at a time one only will be active, or
no,
when
no,
VLAN one
many,
is there.
many spanning tree instances for different VLANs can be active.
Also active means how many are active, it will show all those things.
It will show all those.
Okay.
And it will not show like VLAN 1, 2, 3, 4 like this. No, it will show for VLAN number 1 first, like this. For VLAN
Okay,
number
then-
1, for VLAN number 1 on this particular switch, this is the root switch. It is showing like that. This output is for only for VLAN number 1. And for VLAN number 1 spanning tree, this switch is the root switch. For VLAN number 2 spanning tree, this may not be the root switch. This may be the root switch.
Okay.
Such kind of spanning tree where you can have multiple spanning tree instances for different VLANs. We call that as a per VLAN spanning tree protocol. We'll talk about this later, but just to give you like a heads up, you can create, as I said, multiple spanning tree instances for different VLANs, and it is not necessary that a single switch has to be a root switch for those VLANs. For all the VLANs on the network, for different VLANs, you can have different root switches. Okay, and on those switches, it will show different outputs. So, for example, for VLAN number 1, it will show this switch is the root switch. But when we scroll down and we see VLAN number 10, it will not say this bridge is the root bridge. It will show the cost to reach the root switch. Okay, like this one, switch number 2. Let me open switch number 2. So over here, you can see cost of 19. So it's not necessary that in per VLAN spanning tree protocol, as I said, we'll talk about per VLAN spanning tree later, but in per VLAN spanning tree protocol, this switch is the root switch for VLAN number 1. For VLAN number 10, it may not be the root switch. Over here, instead of showing this bridge is the root bridge, it will show the cost like this. And one of the interface will be a root, not designated. Some other switch for VLAN number 10 may be a root switch. So on that switch, it will show us this kind of output. This bridge is the root. And for VLAN number 10, that root switch will have all its interfaces in the designated. You will understand this even better when we go into the per VLAN part. Okay. But
Yeah,
for
that
now,
will look clear that time. Yeah.
yeah. So here, I just wanted to show you this. When it says active, it shows only for VLAN number 1. Okay. Since there is only one VLAN configure. Okay. Now, here it says root ID, meaning root switches priority, root switches MAC address, right? So this is 32.769. Now, why is it 32.769? We learned that it is 32.768. This is the default priority. Why is it showing 32.769? Okay, why is it showing 32.769? The reason is that the VLAN number, whatever VLAN that you are running the spanning tree for, that VLAN number gets added to the priority. So 32.768 plus the VLAN number, we call that as a system ID extension, ID, whatever. 32.768 plus 1 gives us 32.769. So, for example, if you are running VLAN 10, okay, instead of 1 over here, this was VLAN number 10. So instead of seeing 32.769, you will see 32.768 plus 10, and that value would be 32.778. 32.778. So the priority is always shown in the output with the default priority plus the VLAN number. That is how the priority is usually shown. That is why you will see here 32.769 for VLAN number 1. Based on the VLAN, the priority will change. The priority number will change.
So, but how it will change? Like, suppose for VLAN 1, switch 1 is the root. For VLAN 10, how it will become switch 4 as this? Because it is based on it is based on this MAC address.
For now,
this
as I said, for now, no matter how many VLANs I run, No matter how many VLANs I run, it can be 4096 VLANs that I am running. Switch 1 is still the root switch. Switch 1 will always be the root switch. Okay.
Okay, in this case, in this four.
In this, in between these four, switch 1 will always be the root switch. Now,
Okay.
I can change that as well. I can make switch number 3 the root switch for VLAN number 10 also.
Okay.
Specifically, I'll show you that command later. Okay, I'll show you that command later. But you can make root switches different for different VLANs also. That kind of flexibility is also present in spanning tree protocol.
So automatically will not, because we have to make it. Then it
We
will.
have to, you have to explicitly configure it.
Okay.
All right. And as I said, this number 32769. Okay, let me just add one more VLAN. Configuration terminal. I'll have to create trunk interfaces and all these last time. Okay, configuration. Interface fast Ethernet, interface range, I should mention. Interface range, fast Ethernet 0/1-2. Okay, switch port mode trunk, switch port trunk, allowed VLAN, okay, 1,10, and on this switch we have not created VLAN number 10, so VLAN 10. Okay, and I'll explain what I'm doing. So, okay, but before that, let me also show you. So the moment I do so, what I did, I introduced or I created VLAN number 10 on switch number 1. Okay, on switch number 1, if I do a show VLAN, we will see switch number, we will see VLAN number 10. Okay, that is also now created. Now to see the trunk interfaces, show interfaces trunk, we can see, okay, we can see on fast Ethernet 0/1 and 0/2 of switch number 1, VLAN 1 and VLAN 10 are allowed. Okay, and those two interfaces are in the forwarding state for spanning tree also. And for which VLANs are they forwarding? They are forwarding data for VLAN number 1 and VLAN number 10, both. Okay, now I'll go deeper into this particular output after I show you this one, show spanning tree active. Now, here you will be able to understand what I was saying earlier. So the moment I created VLAN number 10, okay, VLAN number 10, the moment I created VLAN number 10 on this switch, spanning tree started to run for VLAN number 1 and for VLAN number 10 both. And for both the VLANs, this switch is the root switch. You can see for VLAN number 1, this switch is the root switch. For VLAN number 10, also this switch is the root switch. And the system or the priority number you can see is 32768 plus 10, which is 32778. So every time you add a new VLAN onto this switch, spanning tree starts to run on that VLAN. Spanning tree starts to run on that VLAN. And this is an example of it. I added VLAN 10 in this particular switch. Okay, spanning tree automatically started running on that VLAN. And this switch, because this switch is, it shows that this switch or switch number 1 is the root switch for both the VLAN. That means I can have different root switch for different VLAN. I hope now it is clear for you what I was trying to tell.
Yeah, it's now clear.
Right. I can explicitly configure some other switch to be the root switch for VLAN number 10. It may not be a switch number 1. It can be switch number 3. Okay. So now since I've added VLAN 1 and VLAN 10 on switch number 1, let me do the same thing for every other switch. So Now, what I did, I added VLAN 1 was already present. I added VLAN number 10, okay, in the form of a trunk port, so that VLAN 1 data and VLAN 10 data can flow. VLAN 1 data and VLAN 10 data can flow through the trunk interface. That is why I created a trunk port on these two interfaces. So I will do a similar configuration of trunk port on all these switches now.
So you converted from access to trunk.
Correct.
Okay.
So switch number 2, I'll introduce a new VLAN, that is configuration terminal VLAN number 10. Okay. Then exit interface range fast Ethernet 0/1-2 switch port mode trunk switch port trunk allowed VLAN 1, 10. Okay. And now the same for switch number 3 as well. Enable configuration terminal VLAN 10 exit interface range fast Ethernet 0/1-2 switch port mode trunk switch port trunk allowed VLAN 1, 10. And for switch number 4 as well, enable configuration terminal VLAN 10 exit, then interface range fast Ethernet 0/1-2 switch port mode trunk switch port trunk allowed VLAN 1, 10. Okay. Oh, Amatapo. Okay. Now let's look at this from switch. Okay, switch 2 is up. All the interfaces of switch 2 are up. Let's look at switch 2. So show spanning tree active. When I do so, you can clearly see it says root switches ID for VLAN number 1. Who is the root switch for VLAN number 1? And who is the root switch for VLAN number 10? And we can clearly see the switch with the MAC address 384C is the root switch for both the VLANs. And for both the VLANs, this particular switch, switch number 2, its fast Ethernet 0/2 is the designated port. You can see for VLAN number 1 also fast Ethernet 0/2 is the designated port, and for 10 also it is designated port. Similarly, 0/1 is root port for VLAN number 1. For VLAN number 10, 0/1 is the root. Okay, we will see a similar thing for switch number 3 as well. And show spanning tree active. Okay, we can see it says for VLAN number 1, 384C MAC address is the root switch. For VLAN number 10 also 384C is the root switch. And you can clearly see for VLAN number 1 data also this interface is in the blocking state. And for VLAN number 10 data also this interface, the same interface is in the blocking state. Got it? So here, no matter if you leave the network or if you leave the layer 2 network in its default state and you just keep on adding multiple VLANs, the same switch will be the root switch for all VLAN data.
Okay, this is the default behavior.
This is the default behavior. Okay, this is the default behavior because by default, this switch has become the root switch because this switch has a lower MAC. of all these four switches. Out of these four switches, this switch has a lower MAC. That is why this switch has become the root switch. So no matter how many VLANs, you introduce in this network, this switch still be the root switch for that VLAN. Got my point? So even if we introduce 4096 VLAN into this network, this switch will still be the root switch for that particular those VLAN, and this switch or this interface will be blocking for all these VLANs. For all these VLANs. Okay.
But
That is why we, as I said, we'll talk about per VLAN later, but that is why we introduce something called as per VLAN spanning tree protocol, where for different VLANs, I can have different spanning tree instances. For different VLAN, I can have different spanning tree instances. And how can it make so? Let's say this is out of these four switches. I'll just give you a heads up over here. So this switch for now has the lower MAC. Okay. Now, if I want switch 4 to be the root switch for VLAN number 10, for example, how can I make it? Obviously, MAC address, I cannot change it because it's unique. It's built in. I cannot interfere with the MAC address. I cannot change the MAC. What can I change? For VLAN number 10, okay, I can lower the priority. Default, this priority is 32,768 for VLAN number 1 also, for VLAN number 10 also. That is why this switch became the root switch based on the MAC address. Now for VLAN number 10, switch number 4 will still have a higher MAC than switch number 1. If we are trying to make switch 4 as the root switch, it cannot become the root switch based on the MAC address. So the only other thing that you can change is the priority. So we know that by default, 32,768 is the priority. Obviously, it is true for VLAN number 1 and true for VLAN number 10. So what I can do? For VLAN number 10, I can lower the priority. For example, let's say 32 or let's say 4096, for example. 4096. So what would happen?
so this
Root,
priority is for the switch or VLAN? This is a switch priority. The switch priority will be always remaining same. So like if we go to
yeah,
VLAN, how can we change that?
that is why I said per VLAN spanning tree. That is why I said per VLAN. You are creating spanning tree instances for each VLAN, per VLAN.
No, but I'm like the priority, how can we change for different VLANs? Like priority is a switch level, right? Switch
No.
priority.
It's not on the switching. That is why
Okay.
if you see show spanning tree active, is not at the switch level, it is at the VLAN level. So you see for VLAN number 10, you have this priority.
Okay.
For VLAN number 1 also, you have a different priority.
Okay. That means the priority is not switch thing. It is per. Okay.
It's a VLAN thing. So over here, let's say configuration terminal. Okay, I can make spanning tree. What's the command? Spanning tree VLAN 10 root. Simple. I'll say make. I'm saying configure switch number 4. You can see this is switch number 4. Configure this particular switch for VLAN number 10 as the root switch. So switch number 4 for VLAN number 10 will become the root switch, and based on that, for only for VLAN number 10, it will have a different topology. It will have a different topology. I'll uh, I'll explain that later. Okay, but how I think I have digressed from the topic a lot for now. Let me. I was actually discussing this particular. Okay. So I introduced VLAN number 10 and VLAN number 1, and you can see for every VLAN, no matter how many VLANs you introduce, the output remains the same. Okay, the output remains the same. And in the output, we can see it says the root switch is priority, the root switch is MAC address. What is now this cost is its cost to reach the root switch. This is not the interface cost. This is its cost to reach the root switch. Okay, this is the interface cost 90, and this is its cost to reach the root switch. Okay, and via which interface can it reach? It fast Ethernet 0/2. Yeah. So it can reach the root switch via this interface. Okay, it can reach the root switch via this interface. And it says the hello timer is 2 seconds, forward delay timer is 15 seconds. I'll explain max edge timer when we are talking about few other features later. Okay, forward delay timer is 15 seconds. That is the listening state, learning state timer, 15 seconds. And hello timer, the BPD, 2 seconds. Okay, so at every 2 seconds of interval, you have a BPDU created, and whenever there is a change of role, 15 seconds of listening and learning state is done. And this is true for every switch. This is true for every single switch. Is this output clear?
Yes. So
Yeah,
that time you change the priority. That time also again this 15, 30 seconds again it will go for the VLAN 10. You change the
correct.
priority.
Yeah, yeah,
So it will,
yeah,
after
yeah.
30 seconds only it will again
Hmm, hmm.
get back.
Yes. Okay. Now we saw the timers. Okay, the listening state, learning state, and the different forwarding state, blocking state, etc. So if I bring a PC over here, okay, PC 0 or PC number 1, and let me just simply give an IP address, desktop 10.0.0.1, and let me just connect this PC over here. And we will see for fast Ethernet 0/3, show spanning tree. Right? We'll see fast Ethernet switch to only. Yeah, you can see fast in 0/3, it's in the listening state. Now it's in the learning state. Now it has moved into the forwarding state. Now it has moved into the forwarding state. So you can clearly see this interface took 30 seconds to move it, or it took 30 seconds to move into the forwarding state. So when it moves into the forwarding state, then only the data can be sent and received to that interface. Clear? Now, why would a PC wait for 30 seconds? Correct. Why would a PC wait for 30 seconds? So we will introduce something called as the port fast interface. So on fast Ethernet 0/3 of switch number 2, okay. So configuration terminal, interface fast Ethernet 0/3, spanning tree, uh, spanning tree port fast, spanning tree port fast. You can see this is spanning tree port fast, right? And question mark. Okay, spanning tree port fast. Enter. Okay. Now the moment I execute that command, you can clearly see a warning. It says port fast should be enabled on ports connected to a single host only. Connecting hubs, concentrators, switches, bridges, etc. to this interface when port fast is enabled can cause temporary bridging loops. Use with caution. It throws an error. Or not throws an error, it throws a warning. Okay. And again, port fast has been configured on 0/3, but it will work only on a non-trunking mode. What does a non-trunking mode mean? Until and unless that interface is an access mode, your port fast will not work. So you have to make sure that you are running the port fast on an access mode interface, or there is no trunk involved. First of all, there is no trunk configured on that interface, and you are connecting only a single host to that particular interface. You have to make sure about it. Okay. Now let's connect PC1 to switch number 3. And the moment I connect, so you will see it will immediately go into the green triangle. Previously we saw it stayed for 30 seconds in this orange circle, orange mark, and then it turns to the green triangle. But now after port fast is enabled, it will immediately go into the green part. You can clearly see here. It immediately moved into the forwarding state. It did not wait for 30 seconds. So that is the use of port fast. So the port fast is basically used to avoid this 30 seconds of timer. 30 seconds, which involves 15 seconds of listening state and 15 seconds of learning state. To avoid these 15 seconds of timers, port fast is used. And again, as the switch warns us, you should enable port fast only on interfaces where a single host is connected. If you're connecting a switch or any other networking device, it can cause temporary bridging loops. So make sure that you are connecting only an end host to it. Clear with port fast?
Yes, yes, it's clear.
Yeah. Now, okay. Mhm. So now port fast is clear. Let us bring in a switch. Enable. Now let us understand how does a root guard and a BP2 guard works. Okay. So
Now this the route will change from if you connect a switch.
no.
That time we have to.
No, not that.
No, according to theory, we connected extra switch, then the route changed, and then we had to.
Exactly. The same thing. So I'm looking for a switch which has a lower MAC address than switch number 1.
Okay.
Currently, this is the root switch. Correct. So I'm looking for two switches, one switch which has a higher MAC and one switch which has a lower MAC. These two switches, kind of switches I'm actually looking for. So for switch number 1, it is 000004. So it should be less than 0004. It should be 0003, 0002, something like that. Okay. So switch number 5, 006. No.
So these
Is
are
0004. Okay, hold
random.
on a second. No. Yeah. It generates random. 0049 AC2. What is this? 9AC. See, this still is lower MAC. How? Okay. Let's check switch 6's MAC address and switch 1's MAC address. You can clearly see this is switch number 1. Okay. So 0004, 0004, same. 9A, 9A, same. This is B, but this is C. Obviously, B is lesser than C. So this still is a lower MAC address.
Yeah, it's very difficult to get. Like we have to
Yeah,
keep on adding switches. Which one is less than?
exactly. So 0004, 009, no, 0001. Yes, got it. This is switch number 8. Switch number 8. Okay. So switch number 8 has a lower MAC, 0001. Okay. And our switch number 1 has 0004. 0001 is less than 0004. So obviously switch 8, the moment I connect, okay, I'm not introducing any root guards. Okay. But the moment I connect switch number 8 to switch number 3. Okay, not from here. Let me connect it to this part over here. Okay, they will exchange BPDUs. Okay, and you will see something that probably this may not be a block. After some time, you will see this may not be a block. Why? Because the BPDUs will be sent across, and it will learn that some to reach. Obviously, this is a root switch because it has a lower MAC than this one. So this needs to be the root port. This is the shortest path to reach the root switch. Huh?
Okay, got it. So the right side we have connected this, that switch number 8 will become root. So,
Give me a minute. Okay, because we have two VLANs, that is why it's all the links are green. You can see all the links are green because we have two VLANs. Okay.
so
Let
we'll
me.
remove one.
Okay, no worries, no worries. We'll check which is the VLAN, which is the block port for this one. So obviously this interface will not have a block port. Let's check on switch 2. So most probably switch 4 will have a block port. Let me check. Enable. Shows time active. Yep. For VLAN number 1. For VLAN number 1. This is a block port. Fast Ethernet 0/1 is a block port. Okay. This one becomes the blocked interface. This interface has become the block. Previously, this was the blocked interface, but now this has become the blocked interface.
That's for different VLAN.
For VLAN 1.
VLAN 1.
VLAN 1.
But VLAN
Okay,
10.
previously VLAN 10. Okay. Why VLAN 1? We are only seeing this change in VLAN 1. The reason is by default, all the interfaces are part of VLAN number 1. 0/3 is also part of VLAN number 1. I have not created this as a trunk. I have not introduced VLAN 10 on this particular interface. That is why in every output that you see, switch number 4, every output that you see over here, okay, you will see changes for VLAN number 1 only, not for VLAN number 10. This changed for VLAN number 1, but not for VLAN number 10. Because, as I said, I introduced a new interface where I have not allowed VLAN number 10, which is also not a trunk. So your VLAN 10 is running only here between this part. VLAN number 10 is only running between these four switches. So for VLAN number 10, this is a blocked interface. For VLAN number 10, this is a blocked interface. But VLAN number 1 is running between these 5 switches like this. Okay. So for VLAN number 1, this has now become the blocked interface. VLAN 1 data will flow directly out of this interface, but VLAN 10 data will not. VLAN 10 data will flow through this, but VLAN 1 data will be blocked. That is how this is basically the funda of per VLAN spanning tree, which I was talking about.
So the flow routes will change for each of them.
Exactly.
Per
So if I bring that diagram, or let me draw that diagram better. Okay. So switch 1, switch 2, switch 3, switch 4. Okay. For and you have switch 5 as well. Okay. For VLAN number 1, VLAN number 1, okay, there is no link between 4 and 3 for VLAN number 1. But for VLAN number 5, sorry, but for VLAN number 10, switch number 1, switch number 2, switch number 4, and switch number 3. Obviously, we have not configured VLAN 10 over here, so it even does not know there is a switch. that is existing over here. For VLAN number 10, this is how the network is for VLAN number 10. Got my point? So for VLAN number 1, this is the blocked interface. For VLAN number 4, this is the, or 10, this is the blocked interface. VLAN 10 will not flow out of this interface, and VLAN 1 will not flow out of this interface. This is basically your simple funda of per VLAN spanning. Clear?
Yes.
Yeah. Now, as I was saying, switch 8 has become the root switch. So if we just simply do a show spanning tree over here, show spanning tree active, it will say this bridge is the root bridge for VLAN number 1. And you can clearly see the network or the topology change that has happened. It was like this for VLAN number 1 also, and for VLAN number 10, this was the network topology. But the moment I introduce a new switch with a lower MAC address, the topology completely changed. The topology became like this. And this is literally a very harmful thing from a networking point of view. Okay, so I want a mechanism. Okay, I want a mechanism where this thing is stopped. So I created something called as a BPDU guard. What I will do over here, I will enable BPDU guard, not BPDU guard, sorry, root guard. I will enable root guard. I will enable root guard over. Okay, so on switch number 2's fast Ethernet 0/3, enable configuration terminal. Okay, and let me delete this particular link again. Okay, let me delete this interface link again. And the spanning tree will once again run for VLAN number 1. Okay, because 1 missed BPDU, 2 missed BPDU, 3 missed BPDU. So in total, 6 missed BPDUs. That means this is dead. And again, there will be a spanning tree convergence. And you can see now this has become green. Sorry, yellow. You can see this has become yellow. Okay, so now it is back to our original diagram where for VLAN number 1 and VLAN number 10, this is how the network looks like currently. Okay.
Yes.
Now on fast Ethernet 0/3 over here, interface fast Ethernet 0/3 spanning tree command, exact command, spanning tree guard. You can see spanning tree guard. Okay, spanning tree guard. Then again question mark root. Spanning tree guard root. Okay. So now let me connect switch 8 and fast Ethernet over here. Okay. Now on switch number 2, you can see some important information being thrown. You can see it says the moment I connected switch 8 to this interface, it said it went up. However, it says spanning tree root guard block 403 tried to become a non-designated port in VLAN number 1. Tried to become a non-designated port. Obviously, if it is a non-designated port, it can be a root port only. That means it tried to become a root port for VLAN number 1. Why? Because this switch is the root switch. So obviously this interface will be a root port. That is why it said non-designated. Okay, it tried to become a non-designated port for VLAN number 1. And what it said, moved to root inconsistent state. Moved to root inconsistent state. Basically, it's blocking. Basically, it is blocking. Okay.
There is another name for block.
Yeah, root inconsistent state. Okay. So show spanning tree active for VLAN number 1. it says it is, you can see it's in the listening state. Though the role is designated code, but it is in the listening state. It has not gone to the forwarding state. It is in the listening state. Okay, and we can show spanning tree inconsistent. You can see fast Ethernet 0/3 is root inconsistent. Okay, so over here, what happened? A lower MAC address, BPD was received on a root guard enabled interface, and the moment it was received, it moved into a root inconsistent port. Okay, now let me remove the link. Okay, once I remove the link, and let me check the show interface fast Ethernet 0/3. No problem. I'll show you what I was trying. Now switch 8 is a lower MAC address. Any of these switches we know is a higher MAC address. Connect higher MAC address device. So let me connect switch number 5 to this guy. And we will see this has moved into a forwarding state. So show spanning tree active. Okay, you can see fast in 0/3 has moved into a forwarding state. This switch has a higher MAC address. But what if this switch is connected to an intruder PC? He can send direct data now, correct? He can access our network.
You said
So that
anything,
was a problem.
anything you can do from there. Right?
He can do anything. Okay, so that's a problem now. So for a lower MAC address, root guard is okay. But for a higher MAC address, it's a failure. It's a failure. So what we are going to do now, we have introduced, as I said, we have introduced a new feature. Instead of a root guard, on switch, sorry, interface 0/3, we will say configuration terminal interface fast in 0/3 spanning tree BPDU guard. That's all. Okay, BPDU guard enable.
Just
Okay,
one line.
yeah, spanning tree BPDU guard enable. Spanning tree BPDU guard enable. Simple. Okay, now let me connect switch 5, and here we should see this going into, yeah, you can see it now moved into a red triangle. Okay, now what does it say? It says received BPDU on 0/3 with BPDU guard enabled, disabling this interface. And because a BPDU was received, a BPDU error has been detected, and it has moved 0/3 into an error disabled state. So if it is a root guard, it will be a root inconsistent state. Okay. If it is a BPDU guard, then it is error disabled state. Error disabled state. Okay. So no matter what kind of it says a BPDU. It does not say higher BPDU or lower BPDU. It's just mentioned it's a BPDU. I'm going to block it. Let's check that to switch number 8 as well. Switch number 8 has a lower MAC address, right? We just did that. So switch number 8 has a lower MAC address. Let's connect switch number 8. Okay. Now, as I said, when BPDU guard is enabled and a BPDU is received, this interface, okay, this interface is in error disabled state. And To move this interface back to its normal state, we have to manually shut it down and unshut it. So this interface, I think we are on 0/3 only. So I'll do a shutdown. Okay, administratively down, and then I will do a no shutdown. No shutdown. So you will see it briefly went up, but then again it went down. It briefly went up and again went down. Why did it went down? Because there was a BPDU that was received from switch number 8, and again it said received a BPDU on 0/3 interface. I'm moving that interface back to an error disabled state.
Okay, so every time we'll keep moving back to error disabled. If try to
Yeah,
connect the lower
connect,
MAC address.
not lower MAC address, any.
Okay,
We connected switch, see, we connected switch number 5, which had a higher MAC. This had a higher MAC. Even then it blocked. We connected a lower MAC, then also it blocked. So that is the benefit of BPD. It does not check if it is a higher MAC address or lower MAC. It's a BPDU. I'm receiving a BPDU on a BPDU guard interface. I will block the interface. Clear? So now if I try to connect a PC also, okay, if I connect a PC on this interface will still be down because it is an error disabled state. So I have to shut this interface by giving the command shutdown interface and then no shutdown interface. Then only this interface will come up. You can see here. Clear? Any question with root guard or BPDU guard?
No, it
So
is.
root guard, root guard will block lower MAC address, lower MAC than the current root switch. If it is a higher MAC, it doesn't care. It will allow the BPDU to pass in and eventually data will start to flow. But a BPDU guard will not allow lower MAC nor a higher MAC. It doesn't care if it is a lower MAC or it is a higher MAC. All it sees is a BPDU and it will block it. Okay. Sorry. So I think that's it for today's lab. Okay. And in the next lab, we'll look into more advanced feature like per VLAN spanning tree. Okay, which I just showed you how per VLAN spanning tree basically works, but we'll uh, uh, try to understand a bit more about per VLAN spanning tree in the next.
Sure,
Okay,
things are
so
getting slowly clear. Yeah.
yeah, yeah.